Ultrahot Jupiter exoplanet orbits its star in 16 hours. Shane McGlone, December 1, 2021, 8:52 a.m. Central Standard Time. We all know that it takes the Earth 365 days to orbit the Sun, marking an entire year. In our solar system, a year on other planets varies greatly depending on how close it they are to our star. Mercury, which is both the smallest planet and the closest planet to the Sun, takes 88 days to orbit the star. By comparison, dwarf planet Pluto takes 248 years to orbit the Sun. MIT astronomers have discovered an exoplanet described as an ultrahot Jupiter that orbits much more quickly and much closer to its host star than Mercury. Image, NASA, ESA and G. Bacon. While Mercury orbits the Sun at a distance of 35.98 million miles, the exoplanet MIT scientists have discovered orbits only 1.5 million miles away from its host star. Due to its proximity to the star, a year on the planet is only 16 hours long. Its blistering fast orbit gives it the shortest orbit of any known gas giant. The newly discovered ultrahot Jupiter is 5 times the mass of Jupiter. Since the planet is so close to its star, its dayside is estimated to have a temperature of 3,500 Kelvin, which is close to 6,000 degrees Fahrenheit. That incredibly high temperature makes the planet designated T-2109b, roughly as hot as a small star. The incredible surface temperature of T-2109b makes it the second hottest exoplanet ever detected. By comparison, the hottest exoplanet discovered is an ultrahot Jupiter called Calt 9b, with a surface temperature estimated to be about 7,800 degrees Fahrenheit. Advertising. Astronomers believe T-2109b is going through a process of orbital decay which will eventually see the planet consumed by its host star. As it gets closer to its star, its speed will increase, shortening the length of a year on the planet. T-2109b was discovered using the NASA Transiting Exoplanet Survey satellite test, providing astronomers a chance to study how a planet going through orbital decay behaves as it runs towards the star. The lead author of the paper on the discovery, Ian Wong, says if scientists are lucky in 1 or 2 years, they will detect how the planet is moving closer to its star. As for how long it will take before T-2109b is consumed by its star, it won't happen in our lifetime. Wong believes the planet may disappear in another 10 million years. Astronomers began observing the host star, T-2109, using tests on May 13, 2020. The star is located in the southern portion of the constellation Hercules. It lies about 855 light-years from Earth. TESS has been busy discovering stars that may have planets orbiting them, and T-2109 was the 2109th TESS object of interest, which is where its name is derived. The exoplanet was discovered using changes in the light of the star called transits. That technique is commonly used to discover exoplanets orbiting distant stars. During a transit, starlight from the host star dims briefly as a planet passes in front. Using test data, the astronomers determined T-2109b orbits its host star every 16 hours. After determining a planet was orbiting the star, the test team alerted the astronomical community, and multiple ground-based telescopes conducted follow-up observations over the following year. The combined observations confirmed the transit was caused by a planet orbiting the with a mass of 5 times that of Jupiter. T-2109b would be approximately 35% larger than Jupiter. The star it orbits is approximately 50% larger in size and mass than the Sun. Estimates suggest T-2109b is falling into its host star at a rate of 10 to 750 milliseconds per year. Observations also suggest the planet is tidally locked, with one side facing its host star constantly. While estimates suggest the planet's dayside is 3,500 Kelvin, the night side has a brightness below the sensitivity of TESS data. That is an interesting observation, raising a mystery about what is occurring on the planet's night side. The data suggests that possibly the temperature on the night side of the planet is very cold. However, there is the possibility that the planet has processes in place that somehow takes heat from the dayside and transfers it to the. These observations certainly are not the end of observations for T-2109b. Astronomers hope to use more powerful telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, to conduct more detailed observations in the future. The goal is to learn about conditions for hot Jupiters as they fall into host stars. Ultra-hot Jupiters such as T-2109b are the most extreme subclass of exoplanet, according to Wong. Scientists are only beginning to understand the unique processes happening on planets of this type. Researchers are so curious about these processes because we have no comparable processes occurring in our solar system. One of the basic understandings of this type of planet scientists hope to discover is how massive planets like Jupiter can orbit a star in only a few days. Speculation suggests these planets may have begun their life much further away from their host stars and migrated closer to the stars over millions of years. Observations such as this will help answer those questions in the future. Topics: Astronomy, exoplanets, mid-research space. Must-read bits.